CAE analysts often need to edit, create, or delete geometry, but for different reasons and in different ways than designers. However, the geometry editing capabilities of traditional CAE preprocessors can make working with geometry a challenge. In this video, you'll see 3 different cases where CAE analysts need to modify geometry and how NX greatly simplifies the task. Additionally, you'll see benefits of how FE model associativity to the base geometry can be an even greater benefit to your productivity as designs change throughout the development cycle. NX, powered by synchronous technology and its analysis to design associativity, enables engineers to quickly make design changes on the fly, as shown in this plastic case example. You can delete holes or other features from the design that are not relevant to analysis. Next, you can quickly modify dimensions of various geometry features throughout your model to achieve performance requirements. In fact, you can even drag entire sections of your geometry around, and NX automatically maintains design relationships, as you see here as the boss merges with the rib in this example. Since the analysis model is associated to the design, you can quickly update your model to the new design. With this process, you can easily iterate and simulate over several design alternatives in a fraction of the time it takes with traditional CAE tools. In this example, consider a race car exhaust assembly where you want to analyze the exhaust flow through the assembly. In order to do the CFD analysis, you first need to create the fluid domain geometry. By using synchronous technology in NX, you can easily create the fluid domain in just 2 simple clicks. After you've created the fluid domain geometry, you can easily mesh and solve the model, and finally review the results showing the exhaust flow streamlines. But what happens when the designer makes a change to the base design? Suppose the designer makes a change to a dimension on one of the parts in the assembly. Well, this isn't a problem for NX. The fluid domain you originally created automatically updates to the new dimension. Furthermore, you can easily update your entire CAE model, including the mesh and boundary conditions, to the new design at the click of a button, enabling you to quickly assess the impact of the design change on the exhaust flow in just minutes. Now, let's look at a linkage from a helicopter rotor assembly. Suppose you want to optimize the weight of this part by using the length of the arms as a design variable, but still meet performance requirements. By using synchronous technology, you can directly select the appropriate geometry, and by simply pulling on the drag handles, confirm you have the correct geometry defined for the design variable. You can then define a standard optimization solution and assign the geometry modified with synchronous technology as a design variable. Next, set the appropriate optimization limits and execute the optimization. Simple feedback allows you to see how the design variable changes in the objective function, followed by a report where you can see more details on how the design variable affects performance and weight. Finally, you can animate the results to get a clear understanding of what is happening with your optimization results.